Hello, superstars! We are officially starting Chapter 8, Volume. Great news is calculators, calculators, calculators. All right, we're going to go ahead and specifically find the volume of cylinders. Remember, a cylinder essentially is like a can of corn, can of beans, something like that, trying to find the volume, which is all the inside space. Or we could know the volume and then have to find the height or the radius of that specific cylinder. Now, this is the easiest formula that we're going to be doing in Chapter 8, so hopefully you got your notes ready to go, your calculator to be able to help you out, maybe a second color for some of your awesome drawings that you're going to do. So our cylinder is a solid shape. So remember, it is a three-dimensional object, which means instead of area, we are finding a volume. If we were to unwrap it, or called the net, like you guys did in 7th grade, you would notice that there's a circle on the top, a circle on the bottom, and a rectangle wrapped around, kind of like the label, if you will. But that would actually be helping you find the surface area if you were to unwrap it or find the net. But we're trying to find the volume, which again is all of the space inside, three-dimensional. So for example, imagine your circle there. So instead of doing an actual circle, make it like a little bit more like an oval, if you will. Once you have that sketched, then you're going to go ahead and make some vertical line segments on the outer edges. And then you repeat that process at the top, which gives you another oval, if you will. And it gives you essentially a three-dimensional can. Now, the nice thing about this picture here is it helps us visualize that if we can work with our circle concept, remember, a circle is made up of that curve around, which is technically called the circumference, and that's connected to, of course, our radius. So that means if you have the diameter, hopefully you still got that skill from 7th grade, that you can find the radius. So the radius, remember, is from that center point to the outer edge. It is half the distance of the diameter. We're going to make sure that we're going to use our appropriate units as well when we finalize our answer. Right now, it's just a generic R, but it might be like 4 centimeters, 2 centimeters, 3 inches, and so on. But once you have that knowledge, again, with the radius, then you're obviously going to need to know your height, because our formula that we're going to use is using certain numbers, but it's directly connected to our formula with our circle from 7th grade or earlier. So the volume formula, again, is think about your circle. Pi r, and what's that last part? Yeah, that's right, pi r squared. So if you have the base area, which again is the shape of the circle, so volume is going to be pi r squared, we're going to finalize it by multiplying it by the height. The height, again, is the height of the actual cylinder. So our formula, V, representing volume, is equal to pi r squared, and then h. So if you notice, the shaded in right there is representing the area of the circle. And then as we fill it in, that is referring to the height. So one more time, you got your circle, and then as soon as you multiply it by the height, that fills in your actual can, which gives you your true volume. So on your homework, you're going to have several shapes given to you in a nice cylinder form. Some of them, they do not have the pictures, so you could always sketch it, or you can just imagine, okay, I need the radius, what's the number? I need the height, what's the number? But we would love it for you to write down your formula each and every time. Volume is equal to pi r squared h, because that formula today is actually connected to tomorrow's lesson as well. So let's jump into some problems. I don't personally like that one, capital B times h, meaning the base shape, which is the area of the circle. I like the full pi r squared h. All right. It says, when doing any type of calculations, always follow the order of operations. Remember, you're going to square, 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 because it says r squared. Great news is, we're going to ask you to use the formula, do some substitution, and then calculator time. And then at the very end, we're most likely going to have to do some rounding. Now, word of wisdom. The way that we're going to ask you to do it is, instead of using the pi symbol on your calculator, because some of you have that, we're just going to ask you to use the generic 3.14. That's commonly used. So Order of operations, remember, parentheses, grouping symbols. So anything inside your parentheses, grouping symbols, you do that first. Then we go to our exponents. Then you go to your multiplication division, working left to right. Same thing with addition subtraction, working left to right. Really, we're just trying to remind you, you better do your exponent first, the r squared. So for example, if you have this as part of your formula, meaning you've done your correct substitution, you would do your 3 squared before you do multiplying by 4 or even multiplying by pi. Again, just follow the correct order. Everything will be good. A lot of students rock Chapter 8 because you get to use a calculator every single day. So make sure you bring your calculator. 3 squared again is 9. Then you proceed there. 9 times 4 is 36. 36 pi. Now, sometimes we're going to ask you for an exact answer in 36 pi or 36 pi centimeters cubed. That's an exact answer because remember, the pi symbol is an irrational number. It is a non-repeating, non-terminating decimal, 3.14, and then a bunch of other digits. If we use the 3.14 when we multiply, we're going to go ahead and use that little wavy symbol because, again, it's an approximate answer. All right, let's go ahead and try it. It says solve. We're going to give the exact and the approximate answer. So that way you get practice with both, and then you can be able to prepare for the advanced problems. So on our first example, we're going to go ahead and find the volume given this information here. So if you can, go ahead and make a beautiful sketch. If you notice down here at the bottom, it's got the dash, 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 and a curve, which gives us that three-dimensional appearance. So when you're ready, you're going to go in and write down your formula. And we're going to go ahead and recognize which number is our radius. Now remember, the radius is always connected to the circle part. It is the half distance across, meaning the diameter is the full distance. The radius is half. The radius is given to us as a 3. So we write down our formula first. Second step, substitution. So like we said, we're going to keep the pi symbol as is. The 3 is now going to be substituted for the r. Don't forget the exponent outside your parentheses. And then our height is 6. On your calculator, go ahead and type it in. 3 squared times 6. 3 squared is 9. 9 times 6 is 54. We keep our pi symbol. Our units are meters cubed because it's a three-dimensional object. And then to find our approximate answer, all I need you to do is to go ahead and multiply by 3.14. So on your calculator, go ahead and do that for us, please. 54 should already be on your screen. Do times 3.14. All right, if you did that correctly, you should have an exact answer and now an approximate answer. So do your little wavy. We're going to go ahead and round it to the nearest tenths place on your calculator. And don't forget your units. And again, this is our approximate answer. So on your homework and your future assessments, make sure you are reading the instructions. Try and figure out what we want. Sometimes we tell you leave answer in terms of pi, which means it actually has to have the pi symbol, which is the exact answer. If it says round to the nearest tenths place, then of course that's the approximate answer. All right, great job. Let's try another one. This time we have it rotated on the side. Maybe it is a pipe there. So we got a big underground pipe. Notice the number connected to the circle part is the 8. But since that segment is going all the way, meaning edge to edge on the circle, that is our diameter. But we really want the radius. So once you have it sketched, go ahead and write down your formula and do your substitution. Some of you might be sketching still. Others may make it quickly, and you may be on the substitution now. Remember, we're looking for both answers, the exact answer and the approximate answer. If the diameter is 8, then we know that the radius is half of that. So we're going to say the radius is 4. Height is 15. Continue there. So we do our calculator, 4 squared. Remember, you got a nice square button, but you should have a bunch of those memorized by now. 4 squared is 16, so all you got to do is type in 16 times 15. You keep your pi symbol because it's an exact answer. And again, remember, this is called cubic feet or feet cubed. And then when you're ready, just keep the 240 on your screen and multiply by 3.14. The key thing throughout Chapter 8 is don't clear out your calculator until your problem is completely done. Because some of the advanced problems we'll be doing later, you want to use all of those decimals that you have on your screen. And if we multiply, we now have 754.0. We are using the 0.0 because we did ask you to recognize it to round it to the tenths place. So you need one digit after the decimal. And again, it's still cubic feet or feet cubed. All right, so now that we've found the volume, remember that was first part of our objective. The second part is to be able to find the radius or the height. So in order to find the radius or the height, we need to actually know what the volume is. So on this one, without the picture, which is a little bit quicker, go ahead and notate height there. So you can underline it, you can highlight it. That's what we're trying to find this time. So with our volume being 314 and our radius being 5, we again just set up our equation. We do our substitution again, so 314 is equal to, pi is still going to stay pi, r squared, so we're going to say 5 squared, and then of course our height. According to our grouping, our order of operations, we are still going to do 5 squared first, so that means we now have 25 pi, and then of course the h. The h is the unknown, again it is our height. Now on this part, it's very similar to solving equations like we've done before. If we have 3x, we divide both sides by 3. If we have negative 4x, we divide both sides by negative 4. For this one, looking at the unknown h, I actually have 25 pi. Now remember, pi is a number, 25 pi. So really, I just need to go ahead and divide both sides by 25 pi. So I'm going to pull up my trusty calculator app. And what you're going to do again is type in the following numbers. You're going to do 314. And I usually have my students do this in 2 steps because most don't have a super fancy calculator. So go ahead and divide by 25 equal sign. On my calculator, it says 12.56. Now remember, that's not the height because I have to divide by 25 pi. So do one more division, so type in divide by. And then for pi, remember, we're just going to use generic 3.14. So write divide, or type in divide by 3.14, and our answer comes out to 4. Now sometimes, if it's not super duper accurate, it may say 4.00 and then some other digits, which essentially is 4 as well. So the height is going to be 4, and we're going to go ahead and say inches. So I would say don't worry about that part. If you want to do it, you can. Some people like to do 25 times 3.14, and then you divide. I personally like just dividing by 25 and then dividing by pi. But others, you may want to do that. Same answer, though, about 4. And our units, of course, are inches. All right, finding the radius, very similar. Again, decimals really don't concern us because you're using a calculator, so don't, get all weirded out there that the height is 3.5. That's okay. Just use what you got. So for example, if your volume were to say 175.89 or whatever, don't worry about the decimals. Just use them as is. So step 1, write down your problem. Step 2, formula. Step 3, substitution. Volume is 176. Pi is still pi. R, the radius is unknown, so make sure it says r squared. Height is 3.5. Now on this one, I'm not going to square like I did on the previous one because I don't know what the radius is. So it means I can jump right to my division. I'm going to divide both sides by, what do you think? Yeah, of course, the number, 3.5, but don't forget about the pi symbol. So the way I'm going to suggest it again is type in 176, divide by the 3.5, equal sign. You got 50 point and a bunch of decimals. I'm going to suggest 2 separate steps. So now do division symbol, 3.14, equal sign. Again, you can do 3.5 times pi and then divide, but I think the way I'm suggesting is a little bit easier. But the key is to remember we have r squared still. You have not just found your radius. So we're going to say r squared is approximately, on my calculator, it says 16.0145, so about 16. And then if you notice now from chapter 7, we're going to take the square root of both sides and say that the radius is about 4. And of course, we got centimeters. 1 second. Silly lights, always, always, always. All right, so we just found our volume for our first 2 examples. Then we just found the height and the radius on our next 2 examples. Then we're going to extend it to have a kind of tricky problem here. So we've got a toilet paper roll. Everybody has experience with this. A fresh roll, we're going to say, is approximately those numbers given to us. Whether or not it truly has a diameter of 1.5, but that's talking about that inner core, that cardboard roll in the center. Because when we're trying to find the volume of the toilet paper here, or whatever type of object you're talking about, you actually don't have anything in that center core. So we actually need to do a little bit of removal, or cutting out, like from woodshop, or mathematically, just subtraction. So basically, I have 2 cylinders. I got the overall cylinder with the dimensions given to us, a height of 4.25, and then if you notice that radius, or sorry, diameter going all the way across of 4.25. Then I've got a second cylinder for that inner core. The height is still 4.25, but the diameter is 1.5. So we're going to go ahead and set it up as 2 separate problems. So observe here, you got that bigger piece. So the radius is found, if you want to do it on your calculator with me real quick, is just 4.25, which is that big horizontal number there, divide by 2, and that's how we got the 2.125. The height is still 4.25. So I'm going to find the volume of that shape. Then I'm going to find the volume of the inner shape, that skinny cylinder, if you will. I found the radius to be 0.75 because on my calculator I did 1.5, the diameter of the skinny part, divide by 2, and I get a radius of 0.75. Still has the exact same height of 4.25. So again, it's really like you got 2 separate problems, and then you're just going to subtract at the very end. So we've got our formula for each one. The volume is equal to pi r squared h, and we're going to subtract the other volume, pi r squared h. The nice thing is, pi stays the same, height stays the same. The only thing that's changing is the radius. So just a quick substitution and quick calculation. So the key thing is trying to figure out the radius instead of the diameter. So we've got pi times that radius from the big shape squared times height. So go ahead and do that on your calculator real quick. 2.125, press the square button, or do times 2.125, equal sign. You have 4.51 and a bunch. Multiply by 4.25, equal sign. 19 something. If you want to, you can keep the pi symbol right now, or you can go ahead and multiply by pi as well, times 3.14. So we're going to say about 60 something for that big one. You're going to repeat the process over here on the smaller one, quick substitution, and then calculation. At the very end, remember, you're going to go ahead and subtract your two volumes together to find the actual volume of the physical toilet paper, all the little paper sheets together. So on my calculator for 0.75 times 0.75 equal sign, I get about 0.5 something. Multiply it by 4.25 equal sign, I get 2 point something. It's like 39 and some digits. And then if you want to multiply by pi right now, times 3.14, you get about 7.5 something. Now, the one difficult part about multiplying with your pi symbol first is you're going to notice how are you going to do all of that advanced subtraction, because your calculator most likely won't store everything that you need, which is why maybe you want to keep the pi symbol towards the end. I like saying save the pi for dessert, which means at the very end you're going to deal with your pi symbol. So we'd say about 19.2 pi, subtract about 2.4 pi. So let's try that on our calculator now. 19.2 subtract 2.4 equal sign gives me about 16.8 pi. Now we're going to use our pi symbol. Save the pi for dessert. It just will probably make things a little bit easier. But if you want to, you could do it before and use all of those decimals. But sometimes you might be lucky and we say leave answer in terms of pi, then you'll be good to go. But we want you to multiply it, rounding to the nearest tenths. I have 52.752 on my screen, so we say about 52.8 inches cubed. So if you notice, it's really just separating into two smaller shapes. We've done that with our triangles as well. But this time, instead of adding the two numbers, we are subtracting them. Because again, that inner core is kind of like it's removed. Wood shop, you drill it out, cut it out, and so on. Awesome. All right. Last thing, just want to mention your assignment real quick. You've got your formula question there. So when you get it, make sure you work with that. Here's some good information, which does not belong. You did questions like that when you were little kids. You had different pictures, what doesn't belong. You got some basic problems here. Find the volume, find the volume, find the volume, but be careful. This is the diameter. This is the diameter. Then it says find the missing dimension. Well, it wants you to find the height, radius, and so on. So this is the one that I really want you to focus on, number 11. It says 2 cans that hold vegetables are shown. If each can holds the same amount of vegetables, what is the height of can A? So what we really want you to do is say can A, can B. So we can say that the volume of can A, so I'm going to say VA for the volume of can A, is equal to the volume of can B. Now, if you notice, they're both cylinders. And I bring that up is because later on, you might have a different shape to work with. So we know that the volume, again, is pi r squared h. The same thing over here, pi r squared h. So on can A, I know the radius is 1, but the height is unknown. So I'm going to say pi 1 squared, and it's going to say h. On can B, I know it's pi. Let me zoom in for my vision challenge friends. The radius is 2, and the height is 1. So over here on the left, 1 squared is just 1, so we've got 1 pi h. On this side here, we have 2 squared, which is 4, times 1, which is 4 pi. So to find the height, we would just divide both sides by 1 pi, because again, we're trying to isolate that variable. Divide by 1 pi. The great news about this is the pi's divide out, so you don't even have to use your calculator really. So that means the height is going to be 4 divided by 1, so it's going to be 4, and we don't have inches or centimeters, so we just have our generic unit, so 4 units. But the key thing is setting them equal to each other and solving for the unknown. Whereas on number 13, just like the last example we did, you're going to go ahead and find them separately and then subtract. This one, a little bit different. It says to find how many gallons. So you're going to set up your formula. You're going to find how many cubic feet by using your formula. And then right here, it says that 1 cubic foot is approximately 7.5 gallons. So let's say that you do all of your work and you find out that it is 1,200 cubic feet. So the last step, all you got to do, again, it's called a unit conversion, unit analysis essentially, is multiply by 7.5, and then you got how many gallons the pool can hold. And then you got some good review questions there. So again, be awesome. Do the best that you can, please. Be excellent math students.